Since we don't have discussion section this week, the goal of this video is to just bring your attention to the things you need to make sure you know to be able to accomplish Lab 3. So what we have here is the Verilog specification for a 2-to-1 multiplexer. And for the most part, I'm going to trust that you can read the code, and you should be able to interpret it by this point in the class. The important thing here is how the mux is being defined. And so here we have the output is going to be 1 when control is 0, and we have B is going to select B when control is 1. And so this tells you a little bit about how this mux is going to behave. So we should have A when it's 0, B is 1. So that's going to tell you what you want to have happen when you come down here to ultimately build a 4-to-1 multiplexer. And so the things to pay attention to is I've got A, and so I want to make sure that that is being selected when our control bit is being 0, when we're going to start spanning this up, because as you can see here, A is going to be when 0, 0. So the control bits, you will want them to be 0 to make sure that works. So putting A here is one of the logical choices. And then because B has a 0 and a 1, let's just put that one here for now. And then the key thing you're going to need to make a decision about as you allocate the control bits is you want to look at the control bits. So is control bit 0 the bit that's different, or is it control bit 1 the bit that is different between A and B that will let you actually choose between these two inputs? Same thing with, you've got C and D. If you were to put those guys here, look at your control bits. Is it control bit 0 or control bit 1 that is different between these two data inputs? And so as you look at that, make sure you're understanding how that works, because that's going to scale up. You want to always be paying attention to the binary encoding that is associated with each input or data input. And then you're going to be writing the code down here to finish this off as part of the discussion section. I'd recommend you do this, check your answers with a friend, and then you're going to scale that up to a 4-to-1 multiplexer. The second problem on the discussion section worksheet is mainly a check to make sure you understand the new notation that we introduced in the Piazza video that we sent out earlier over the weekend. And so here, you're going to notice a lot of these new notations. You're defining a constant much like you would do in a programming language, except here we're defining it as a signal and we're saying what the signal is. So make sure you know how many bits the signal is and what the value of that signal is, and or what this constant is going to be. Second part of this problem that is what this problem is here to help you make sure you understand is what this command means, the assign command. What does that operation do? How does that make this work? So you can see here, this line in particular, what is happening here? All right, like how would you draw that as a circuit? Make sure you understand how that works. And then finally, the last part of this is this double equal sign. Again, this is similar to what you've seen in some programming languages, but it is different. We are implementing a physical circuit here. So the question that you need to be able to understand and recall from this exercise is, what circuit implements this double equal sign? And if you can understand that, you should be able to use this to help you in your Lab 3.